This video is going to go over the ideal gas law, which is something that we learn in Chapter 6, and it's for the Chem 101 students, or anybody interested. So, I found a sample question in the book, in the text, it's number 50 at the end of the book, that we can use to illustrate this question, right? So, the question says an airbag uses a canister of CO2 that's large enough to inflate 67 liters of a bag at 18 degrees Celsius and 1.04 atmospheres. What is the mass of CO2? So here's what I'm thinking. We are given a volume, we're given a temperature, and we're given a pressure. And then it's asking what is the mass. So the way I'm thinking about this is not a Boyle's Law, Charles Gay-Lussac's, or Avogadro's situation, because it doesn't give us two scenarios, it gives us one scenario, right? And it's asking for mass. Well, what if I found moles? Then I can turn moles into mass. So that's just one extra easy step. So my goal is to find moles, then turn to grams, right? So let's define our terms. PV equals nRT, so we have P times V equals nRT, and we went over what units these have to be in. So let's break down and find out what terms we have. So P, do we know P at this point? Do we know the pressure? Yes, it's 1.04 atmosphere. So what I like to do is let's just write down what terms we have, and then we'll determine if they're in the right unit, correct unit, that we could just plug it in. Volume, do I know volume? 67 liters. And then N, do I know N, which is a number of moles? I don't. So this will be my unknown, number of moles. Do I know R? R is 0.0821 liters times atmosphere divided by Kelvin times mole, right? So this is a given. This will always be given. We don't have to, question this. And temperature, do I have a temperature? I do. It is 18 degrees Celsius. So if you ever wonder what units pressure, volume, and temperature have to be in, you just have to look at the constant, which you will be given this on an exam. So pressure has to be in atmospheres, check. Volume has to be in liters, check. And temperature has to be in Kelvin. It's in Celsius right now, so we have to change that. So remember, 273.15 plus degrees Celsius equals Kelvin. So we just have to take 273.15 plus the 18, and that's going to equal our Kelvin. So let me pull my calculator out. So 291.15. So this is really 291.15 Kelvin. That's the same thing. So now I can plug these in. So since I know they're all the correct unit, I'm not going to bother writing the units in when I plug it in. So P is 1.04. V is 67 equals PV equals N, which is my unknown, times R, 0.0821, times T, which was 291. So you may be wondering why I dropped the 0.15. It's a significant figure rule. This only goes one digit past, or this doesn't go any digits past. This only ends at the whole number, so we can end this at the whole number, 291. So let's go ahead and solve this. So 1.04 times 67. This side is 69.68 equals 0.0821 times 291. This is 23.89 CHEM101 N, right, or X, whichever one you'd like to represent it as. So then I take this 69.68 divided by that, and I get N equals 2.91. We'll end it at 2.92. How about that? 2.92 moles. And what is our gas? CO2? Moles of CO2. Perfect. So the question's asking for mass of CO2. We did the hardest part. We found moles of CO2. So we found this part. So how do I turn grams to moles? Or, I'm sorry, backwards. How do I turn moles to grams? You use the molar mass, right? So what is the molar mass of CO2? CO2 is going to be, I'm full of mistakes today, aren't I? It's going to be 12.011 plus 2 times 15.999. So $44.009 grams per mole, and we'll do the final work down here at the very bottom. So we know the molar mass, and I know how many moles. So start with what you're given, put it over 1, 2.92 mole, right? Times, and I have grams per mole. I'm going to want mole on the bottom, so it cancels out with this mole. And my desired unit is grams, correct? So I'm going to say 1 mole weighs 44.009 grams. So multiply by the top, divide by the bottom, so essentially just multiply 2.92 times the 44 divided by 1. So I get 128.5 grams of CO2. Now it may look like a whole lot, it may look like a very involved problem, but please remember I wrote the question quite big. So that's our practice on the ideal gas law. I do hope that it helped out. Good luck with that, guys.